Hello class, these are notes for Algebra 2, and today we're looking at an introduction to sequences for Unit 1. So a sequence is a list of objects written in a definite order. We call each one of those things in the list a term. So you'd have your first term, second term, third term. A sequence can either be finite if it has a finite number of terms. So that means it stops, like 2, 4, 6, stops at 6. Or it could be infinite if it goes on forever. So that would be like 2, 4, 6, dot, dot, dot. So the position of a term in the sequence is usually denoted by n, and the value by f of n. So like this one would be my first term, so like my input is 1, my output is 2. This is my second term, so my input is 2, and my output is 4. So f of 2, so f of the second term is going to be 4. The rule for the sequence above, well, if my first term is 2, my second term is 4, my third term is 6, hopefully you can see this pattern that we're just multiplying, right? 1 times 2 is 2, 2 times 2 is 4, so we're multiplying by 2. So this is going to be f of n equals 2n. And we'll work on lots of strategies to write rules for them as we go along. So if this is something that you really struggle with, we'll have some hard and fast rules for that later on. So don't worry too much. We'll work on it. So now we're looking at arithmetic and geometric sequences. So arithmetic is a sequence where the difference between consecutive terms is a constant. The difference is called the rate of change, because it's kind of like a slope. It is like a slope. It's exactly like a slope. Or the common difference. And for this, because it's common difference, we use a D. So this is like when we're adding or subtracting. So if you can go from one term to the next by adding or subtracting, then it's arithmetic. A geometric is a sequence where the ratio between consecutive terms are a constant. This ratio is called the growth factor. Or the common ratio. And so we normally use an R. So growth factor would be like our Algebra 1 word for it when we looked at exponential functions. So the way you would get from one term to the next in a geometric sequence is by multiplying or dividing. And really we just say multiplying, because if we are dividing by 2, we're really multiplying by 1/2. So we try to look at it as multiplying. But I'm going to write multiply or divide over here. So arithmetic basically is going to relate back to something that is linear. If you're multiplying or dividing, that's going to relate back to something that is exponential. So these are just giving you like Algebra 1 words for the kinds of functions we've studied before. So in number 1, we're going to be just writing the first 4 terms. So in order to find the first term, I'd want to find f of 1. So to find f of 1, I'd put 1 in for all of the n's, and I would get -3. To find f of 2, I would put 2 in for all of the n's, subtract and simplify. F of 3, after you do the work for 3 of them, I'm okay if you can see the pattern that you're just writing down the 4th one. So -3, -2, -1, I can see that they're going down by 1 each time. So I know that f of 4 is going to be 0. And then I do want to make a list. So my first 4 terms are -3, -2, -1, 0. So I don't want you to show work for just 1 or 2 of them. I really want you to make sure you understand the pattern. So on the next one, it looks like I have 2 raised to a power, and n is in my power. So f of 1 would be 2 to the 1 plus 1 power, 2 squared, which is 4. F of 2 is 2 to the 2 plus 1 power, 2 cubed, which is 8. f of 3 is 2 to the 3 plus 1 power, 2 to the 4th, which is 16. And now if I'm just kind of looking at these numbers, 4, 8, 16, I can tell what the next one's going to be, right? It's going times 2 times 2. So f of 4 is going to be 32. So then make a list. My terms are 4, 8, 16, and 32. Next is an arithmetic sequence with f of 2 equals 8 and a rate of change of -2. So remember I said rate of change is when you're like adding or subtracting every time. So my second term, so I'm going to have, I don't know what my first term is, right? But my second term is going to be 8. And then I'm trying to find, I guess this is still part of 1, so I'm trying to find 4 terms. So let's think about how the rate of change is 2. That means from 8 to the next one, it's -2. From this one to this one, it's -2. From the first one to the 8, it's -2. So that's going to allow us to go back and fill in everything else. So 8 minus 2 would be 6. 6 minus 2 would be 4. And then the number at the beginning that would work, I could either work backwards and say, well, 8 plus 2 makes it 10. Or I could just kind of like do a guess and check. Like if I put 10 there and -2, now I've got 8. Next couple we're going to look at in number 2, writing things in words and thinking about these sequences. So first I want to know arithmetic or geometric, so I've got to figure out, am I multiplying or adding and subtracting? So right away I can see from one term to the next I'm adding 3. So that means it is arithmetic. My next term, if I kept adding 3, would be 13. And I'm just going to write add 3 to previous term. All right, on the next one, 3, 9, 27. Right away I'm thinking times 3, so let's double check that. So this would be times 3. Times 3 again. Yep, it definitely works, times 3. So since I'm multiplying, that's going to be geometric. And we would write those as some kind of exponential function. So if I keep multiplying, 81 times 3 is going to be 243. I guess they're all negative, so negative 243. And we would multiply each of the previous terms by 3. So last one, we're looking at just, is it geometric, arithmetic, or neither? If it's arithmetic, we want to state the rate of change. If it's geometric, we want to state the growth factor. It should be growth factor. And remember, when we say rate of change, we're really also talking about the common difference. So that's where the D comes from. And then our other words for growth factor is our common ratio. So it's interesting to me, like if we're working with an exponential function, we would talk about possibly a growth factor, but then as soon as we're doing something different, we're looking at just a list of numbers, we say common ratio, but they're really the same thing. But I think that can be confusing. It's like we're learning lots of the same names, or lots of different names for the same thing. So I always look for adding and subtracting first because that's really easy. So this one, I'm seeing a +2. And if you'd like to stop the video and try this on your own, that's probably a good idea. So this one I'm seeing +2. So that means it's arithmetic. And D equals 2. Next one looks like subtracting. What are we subtracting by? Let's see, first I'm subtracting 5, then I'm subtracting 6, and then I'm subtracting 4. So, oh, but then it's 7, so it's not even really a pattern. I thought we were kind of decreasing there with the amount we're subtracting, but it's not even that. So this is just neither. And even if this was 3, it would still be neither, right? It's not, we're not subtracting the same number every time. We're not multiplying every time, so it doesn't fit. This next one looks like we're multiplying by a fraction. So to figure that out, I'm going to take 128 and divide by 512. to figure out what that fraction is. And that gives me 1/4. So that means this is 1/4. And then next I can tell it's a 1/2. And then next I can tell it's a 1/8. So that's also neither. I'm not multiplying by the same thing each time. The last one, this one is definitely going to be geometric. I can already see it. So times -4 times -4. So r equals -4. This is just meant to be a quick intro today, so we're not writing a lot of rules yet. It's mostly just, can we recognize the pattern, and can we kind of learn some basic vocabulary about them. So as always, if you need help, please make sure you ask.